Chapter 4, Section 3, our objective is to identify independent and dependent variables and to write an equation in function notation and evaluate a function for given input values. So independent variable is the input of a function. It's also the x value, generally speaking. Dependent variable is the output function. You can usually see it as the y value. Function rule is an algebraic expression that defines a function. For instance, 5 times a, that would be a function rule. It's telling you what to do. Function notation, a little different, where x is the independent variable and y is the dependent variable, so we have to know what variables we have. So y is, let's see, variable then y, so f of x, so f parentheses x close parentheses, you can read it as f of x, where f names the function. So it can either be y equals 5x or f of x equals 5x. So this is just another way of giving a name. It can be y, it can be f of x, it can tell you what your independent variable is. That's right here. Whatever's inside the parentheses will be your independent variable. So in example 1, it says using a table to write an equation, determine a relationship between the x and y values. Write an equation. So what's happening? Well, I could multiply by -2 and get -2. But if I multiply by -2 here, I don't get -1. I would get -4, so that doesn't work. 1 to -2, I could take 1 and I could subtract 3 and get -2. See if it works. If I take 2 minus 3, I would get -1, so that works. 3 minus 3 equals 0. 4 minus 3 equals 1, so that works. Looks like what we're doing. So now our y equals -2. So we have y equals, well, what's changing? It's our x value, so x. And what's happening each time? We're subtracting 3, so there's our rule. Example 2. Identify the independent and dependent variables for each situation. In the winter, more electricity is used when the temperature goes down and less when the temperature rises. So what can we control? Which one is dependent on the other? So the temperature is outside and we can't control that, but electricity changes based on what we can't control out here. So I would say electricity depends, depends on the temperature. So your dependent is electricity and your independent is temp. The cost of shipping a package is based on its weight. So the cost is dependent on the weight. So cost, if it's dependent on something else, cost is your dependent variable, while weight is your independent variable. The faster Ron walks, the quicker he gets home. So another way of saying that is the time it takes Ron to get home depends on the speed that he walks. So time, length of time is depending on speed. So time, in this case, one of the rare times that you can say that time is dependent, and speed is independent. Example 3, identify the independent and dependent variables. Write a rule in function notation for each situation. A lawyer's fee is $200 per hour for her services. So we had fee. We don't know exactly how long we are going to be working, so that is dependent, while hours is independent. And we can say F of, we'll call it H for hours because that's our independent, is equal to 200H. The admission fee to a local carnival is $8. And then we want to ride rides. We have to add more onto that. So $1.50 per ride. So our independent and our dependent. Let's see, the total cost depends on the number of rides that we want to ride. So dependent is cost, while independent is number of rides. So we could write this as F of R is equal to 8 plus 1.5 R. So cost is equal to these two added together. Example 4, evaluating. Evaluate each function for the given input values. So f of x equals 5x. Find f of x when x equals 6 and when x equals 7.5. So we're just substituting in. So f of 6 equals 5 times 6. So it equals 30. F of 7.5 equals 5 times 7.5. So 37.5. It's as easy as that. For g of t, when t equals 2 and t equals negative 5, so g of 2, 2.30 times 2 plus 10. So here we get 4.6 plus 10, or 14.6. G of negative 5 is equal to 2.3 times negative 5 plus 10. So we get negative 11.5 plus 10, which is a negative 1.5. Another one. So h at 12 is equal to 1/2 times 12 minus 3. So we get 6 minus 3, which is 3. We get h of negative 8 is equal to 1/2 times negative 8 minus 3. So we get negative 4 minus 3, or negative 7. Example 5. Manuel has already sold $20 worth of tickets to the school play. He sold 20. That's important. He has 4 tickets left to sell at $2.50 a piece. Write a function rule to describe how much money Manuel can collect from selling tickets. Let's see. Find a reasonable domain and range for the function. Let's see. 4 tickets left to sell. We don't know how many tickets he's going to sell, but we know it's going to be the 20 plus 4 times however many tickets we... I shouldn't have done it that way. Okay. Plus the amount it costs per ticket times however many we're going to use. We know that if he sells 0 tickets, we're at 0. If he sells 1 ticket, we're at $22.50. If he sells 2 tickets, 25. If he sells 3 tickets, he's at $27.50. And 4 tickets, he's at $30. So we could have a domain. I want a domain in range, correct? A domain of 0, 1, 2, 3, or 4 tickets, and our range would be 0, 22.5, 25. Should be at 20, because if we have 0 here, we sold 0, so we have $20 to begin with. $27.50 and 30 would be our range. Our homework starts with number 13. Determine a relationship between the x and y values and write an equation from 1 to negative 2, 2 to negative 4, 3 to negative 6, 4 to negative 8. I could add, I could say 1 minus 3, but then 2 minus 3 would give me negative 1, so not that. And I'm getting bigger, a lot bigger each time, so maybe I can multiply by negative 2 and get negative 2, multiply by negative 2 and get negative 4, multiply by negative 2 and get negative 6, multiply by negative 2 and get negative 8. So it looks like I'm taking negative 2 times something, so y equals negative 2x.